So today what I had decided to do is talk about different types of problem-solving strategies, or look at a way of being able to look at something step by step, so as a way to be able to, first of all, read and understand a problem and then find a starting point and figure out how you're going to solve it. So problem solving in a South African context constitutes 15% of any paper that you write. So for grade 11s and matrics who are regularly writing papers out of 150 marks, if it is 15% of your paper, 15% of 150 marks is roughly 23 marks. Okay, so what you will find is that approximately 23 marks in a 150 mark paper, or 15% in any other paper, will be problem solving. Now, what we seem to do in the CAP syllabus is we seem to build a question up. So in other words, when you've got, say, question 5, and you've got from question 5.1 to, say, question 5.6, what you will find is that question 5.1 and 5.2 and 5.3 and maybe even 5.4 are going to be your level 1, level 2 kinds of questions. So that's going to be your knowledge and routine procedures. Thereafter, all right, the questions will become more difficult, so complex types of questions, and then problem solving. So normally problem solving is the very last question will be a problem solving question, or it could be a question that's on its own that's not related to something else. You will identify a problem solving question because it's generally a non-routine problem. So when we talk about something being non-routine, we talk about it's not the usual kind of question. So it's not like prove these two triangles similar, or show that this angle equals X, or prove that this is a cyclic quad. Those are more routine types of questions. So it's going to be something that is non-routine, a little bit unusual, and there is no obvious place where to start. All right, I think that's really important to identify. The other thing to note about problem-solving questions is that they use higher order reasoning and processes. That's why there are so many of us that struggle to answer these questions, because a deep conceptual understanding of the information and how everything works is involved. All right, so yes, Taylor, you raised a hand. Did you want to ask a question? Oh, okay, no problem, no worries. All right, and then as I was saying, let me just move this out of the way for us over here. What may have to happen is that you may have to break the problem down into its constituent parts. So what that means is that in problem solving, sometimes you realize, okay, you need to do this. But in order to do that, you first need to be able to have this and this and this in place. All right, so you've got to be able to go and sort out those smaller things, put them together in a certain way in order to be able to answer the question. All right, so just be aware of that, and that is what's going on. So what I wanted to do is go through some problem-solving strategies that I use myself when I'm trying to problem solve, and this is what I teach my students at school as well. And I want to use the first example as a way of being able to model what it is that I'm trying to say to you. Okay, so what I've done today, and I did say this a little bit earlier, but I'm just going to say it again now. The grade 11s would not be able to do all the matric work, obviously. The matrics can obviously do all the grade 11 work, but the grade 11s can't do all the matric work. So because both groups of learners, grade 11 and grade 12, have just finished geometry, and it is a section that lends itself nicely to problem solving, I decided to use geometry to model what it is that I'm going to say today. Obviously, we could do problem solving in any question, and if we do, once the year progresses, and we've covered other topics like trigonometry and analytical geometry and that kind of thing, then we will be able to go and have a look at problem solving in those sorts of sections as well. So that's just the reason why I've decided to do it this way. All right, so the first thing that I wanted to suggest is that when you are reading a particular problem in maths, make sure that you read the problem carefully first. So many of us, myself included, will just go straight and look at the diagram. So if you look at what's on the screen in front of you, we just go and we look at the diagram and then we read the questions and then we sort of think to ourselves, well, why? Like how is that? And it's because we have not read the information that comes with the diagram before starting to look at the diagram. So tip number one, always read the problem carefully first. All right. What I also want to suggest is that you highlight important information and ensure that that information is not just at the top, but that you've also written it down or that it's visible on the diagram as well. Okay, so if we have a look at what I'm using as an example, hopefully that's big enough and everybody can see it. It says in the diagram, O is the center of the circle. So now, which word in that sentence do we think is a keyword that we should highlight? Is there anybody who would like to unmute and
diameter, ma'am?
Diameter. Imihle? Diameter? I don't see the word diameter. Did I misunderstand you? Yes. Okay. So Kamveletu and Sipusihle, that O is the center. I quite agree. The word center is super important in this particular case. When we read that O is the center of the circle, what does this mean for us? What does it mean? So we see the word center. Tisha, go for it. What does the word center mean to you? Tisha, you can speak if you could be unmuted, please. Okay, so I see some people are posting in the chats. Absolutely, OC and OA are radii, 100%. It's a starting point, perpendicular. I'll just go down here. AC is a chord. Yes, it is, absolutely. What I'm trying to get you guys to do is that when you see a keyword like this, start thinking about all the theorems that are associated with that word. Okay, so for example, if we know that we've got the center of the circle, we might start thinking angle at center is twice angle at circumference. But yes, in this particular case, that wouldn't work. But absolutely, if we have got a center, it means we've probably got a diameter or we have radii. So in this case, we have radii. How many radii do we have? How many radii are there? Yes, there are 3. Yeah, quite right. There are 3. So in this case, we can see that OC is the same as OD is the same as OA. Right? The other thing that's important, if we read on a little bit further, is that chord AC is perpendicular. AC is perpendicular to radius OD. Right, so now the word perpendicular is also really important in this context. What are they telling us? What does it mean when they say that a chord is perpendicular to a radius? What does that mean? I'm going to just look in the chat.
90 degrees.
Okay, so everybody's saying 3. Awesome, awesome, awesome. Okay, so what does it mean when they tell us what's, okay, Aisha, Pythagoras could form, absolutely. All right, equal in Jabulo, what's equal? What's equal? Exactly. Okay, Cornita, you've said the chord is bisected. Good. The radius and the chord form a 90-degree angle. They certainly do. Jessie, AB is equal to BC. Absolutely, that's exactly what it means. Jessie, well done. Okay, so when they tell us this, it means that AB equals BC. Jessie, do you know the reason why? Why is AB equal to BC? Not because of I'm talking about the geometrical reason. So in other words, if the first thing that you wrote on the page was AB equals BC, what reason would you use to substantiate that statement? What would you say? And if not Jessie, then anybody else? Does anybody else know what reason we would use? There we go. Line from center perpendicular to chord. Well done, Panita. Okay, line from center bisects the chord. Perp to chord. Okay, so Otsile, it's very easy to get confused because there are two situations here. There's line from center perpendicular to chord, and there's line from center to midpoint of chord. When the diagram comes with the 90-degree corner, okay, so when you were told that one line is perpendicular to the other, that is the reason with the word perpendicular in it. All right, so in this particular case, that would be line from center perpendicular to chord. All right, good, well done. The other bit of information that they've given us is perpendicular to radius OD, lovely. They've also told us that OB is 2x units long, and they've told us that AC, so this entire line over here, is 8x units long. All right, now that we've had a look at the diagram, we've written the information onto the diagram, we've read carefully what it said, we're going to read the question. Show that the length of BD is 2x bracket root 5 minus 1 units. So can you see what I mean when I said it's going to be non-routine? Okay, that's unusual. It's not something that we see all the time, right? And that's why this is a problem-solving sort of question. Also, it's out of 5 marks. So that's another hint that it's obviously some kind of problem solving. All right, so as I was saying, what we wanted to do is read the problem first. We've done that. Number 2, highlight important information and ensure that information is also on the diagram. Well, we've done that as well. Then it says use keywords to make connections to the theorems you need for the solution. All right, so now in this instance, this is what we've done with the blue, right? We said to ourselves, what does perpendicular mean? It means AB equals BC, and that links to one of our chord theorems, line from center perpendicular to chord. Okay, so something that I think is really important is that when you read information or when you read a question, always ask yourself, what does this mean? Or like, so if they say to you, prove that a line is a tangent to a circle, what does it mean? Right, which angles do you need to prove are equal to one another? All right, or if they ask you to prove 2 pieces of a line are equal to each other, what does that mean? What do we need in order to be able to do that? All right, so look at what they're asking you to prove and see what this line or angle is also equal to. Look for connections between the known and the unknown. So a lot of the time in geometry, especially when we've got those sorts of questions that build up to a problem-solving question at the end. So like I was saying at the beginning of the lesson, 5.1, 5.2, 5.3 are the easy things. We're going to go back and we're going to look at the problem that we've been given, and we're going to try and make connections between something that we've already done. In this case, there's no connections for us to make. They've literally dropped us into boiling water. We don't know where to start with this, okay, which is, we'll talk about that now. And then often in geometry, we need to work backwards. And finding the starting point can be quite tricky, which is why it's important to look for these connections. And then my 6th point, write your answer in a logical, stepwise way, remembering to use reasons. So that's something that I also want to stress with you, grade 11s and grade 12s. You must absolutely get into the habit now that when you write something, you write a statement, you write the reason straight away. All too often we'll write our statement and then we'll proceed with the problem and we'll work out the answer, and then we're like, cool, lacquer, move on, and then we've left off a reason. Okay, and then we end up throwing marks away unnecessarily because of that. All right, so statement, reason every single time. Okay, so now there's no connections for us to make. They've literally just dropped us in the middle of this problem, and they've told us to show that BD is 2x, as we say, root 5 minus 1 units long. All right. What's the first thing that you think of? I know the first thing I think of, but what's the first thing that you guys think of? What's going through your mind right now when you read, show that the length of BD is this? Do you want to put something into the chat? What's the first thing you start thinking about? Okay, so David said Pythagoras. Okay, I can understand why, because there's a right angle triangle. Lovely, David. Perfect. In fact, I think that's a great idea. Yes, theorem of Pythagoras. Good, yes, I agree. So I'm going to put that on the side over here, Pythagoras. Okay, what else do you think of? I mean, besides Pythagoras, and I agree with you, Pythagoras is a super, super important part of this. What else do you think? Not Pythagoras, though, something else, something different. What else do you think? Yes, Celia, I would do the same thing. Oh, someone said distance formula. Okay, so Teresa, why are you thinking about distance formula in this particular question? You mean because they said show the length? Midpoint theorem. Okay, I can understand why you would think that. Sorry, did somebody want to ask a question?
Ma'am, is zero, I mean, is OC equal to OA, and once we get OC or OA, we'll be able to get OD?
Exactly, 100%. That's really, really nice. Okay, that's excellent. Well done. Okay, so midpoint theorem is not going to help us in this particular case because we're not working with coordinates. It's a good idea, but we're not working with coordinates. And it's the same idea with distance formula. We're not working with coordinates. So to think about distance formula in this sort of question is not going to help us. Now, I really, really love what, I think it was Tantawetu, sorry if I got your name wrong, has just said to me now, you are 100% correct. And then the other thing, Kamveletu has said OD is, what are you saying, Kamveletu? OD is BO plus BD, perfect. Okay, so I just want to put that on the page, all right? The other thing that is important here for us, guys, is that OC, OA, and OD are all the same because they're all radii. Right now, that's something that we had already decided in the very beginning. And then I love what you've said, Kamveletu. Okay, you have said that in order to get OD, line OD is made up of 2 line segments in this case. It's going to be OB plus BD. Right, which means, Matrix, that if we want to make BD the subject of the formula, right, if we want BD to be on its own on one side, BD is going to be OD minus OB. Maybe. Okay, that's maybe how we're going to have to get BD in this particular case. Does that make sense to everybody? So we've sort of highlighted what the problem has given us. We've looked at things and we found which parts are equal to one another. The part that they're asking us to calculate, we've decided on its constituent bits and how it is made up. All right. Now we've got to start putting a plan together as to how we're going to go about answering this particular question. Right. So instead of me telling you, I'd like to hear your ideas because they are really amazing. Why don't you, unfortunately in Jabula, it's not going to be proportionality. There's no proportionality in this question because the grade 11s haven't done proportionality intercept theorem. Okay, so unfortunately not, but that's why I tried to choose questions that were completely unusual and therefore problem solving. All right, so as I was saying, guys, put your ideas into the chat. Where do you think we should start? What do you think is the first thing that we should write on the page? You want to do the theorem of Pythagoras, but can you just jump straight into Pythagoras? Is it okay to do that? What do you think? You pop something in the chat. Aisha says, is B not 4x since AC is 8x? Otsile, construct AD. Start with the chord being bisected. Lovely. Okay, there's some really, really nice ideas. Okay, Otsile, you must be very careful about constructing. All right, the only time that you would do constructions is when you are proving a particular theorem. So don't go and construct lines in a question like this yourself. You generally shouldn't need to. If there are any constructions necessary, then the question should come with them. All right, good. That's a really great suggestion. So start off with the bit. You guys are saying, I should find the length of AB. Mamelo, I agree. All right, let's find the length of AB. All right, so how long is AB? What's AB equal to? Yes, Cassandra, we would need to find AB or BC to use Pythagoras. That's perfect. 4x. Awesome. Okay. Well done, guys. That's exactly it. Okay, so AB is equal to 4x. What's our reason? Pop the reason in the chat. Cool. Indeed, ASIS. AB equals BC equals 4x. What's the reason? Why does AB equal 4x? Okay. Kanita, very, very close, right? Just be careful. You got your words just a little bit jumbled up. So line from center perpendicular to chord. Okay, so no, not bisects the chord, Caden. Not bisects the chord. Line from center perpendicular to chord. Line from center. Yes, Zakira, this is grade 11 and grade 12 together. Line from center, perpendicular to chord. Okay, so the line from center that's perpendicular to the chord cuts the chord in half, okay, or bisects the chord. That is why AB is equal to 4x. Lovely. So now that we've established how long AB is, what's next? Oh, okay, Cassandra, before we carry on, guys, good question. Why is it not bisect? Okay, Cassandra, it's very easy to get confused, right? I'm just going to hop over to the side over here. Not too far over, just a little bit over. And I'm just going to very quickly explain this because I'm sure if you're asking it, there are a bunch of people who probably want to know and maybe. Okay, so those are two very badly drawn circles. There is the center. There's a chord. Here is a line from the center perpendicular to the chord. And here is another chord, and we've got that over there, and I've got that situation. So these two are converses of one another, all right? In the diagram on the left, all right, if this is O and this is M and that's A and that's B, all right, we are saying here that what is being given is that OM is perpendicular to AB. Remember in the beginning I was saying to you, if you've been given something, what does it mean? So what it means, the conclusion, the deduction, all right, what you are reading into this is if this is what you have been given, then it means that AM equals MB, because the line from the center, sorry, there should be a space there, line from the center, so O to M, that is perpendicular to the chord AB, right, will cut the chord in half. Okay, so that's line from center perpendicular to chord. On the diagram on the right, if this is O and that's M and that's A and that's B, it's the converse of the one on the left. Here, we have not been given a right angle. We have been given that AM equals MB. What does this mean? Okay, so if there is a line from the center and it touches a chord and it touches the midpoint of the chord, so the chord is cut in half, then it means that the line from the center is perpendicular to the chord because it bisects the chord. So then we will conclude, okay, that either you can put it one of two ways, either OM is perpendicular to AB, or I suppose the other way that you could say it is that either OMA or OMB, OMA or OMB are equal to 90. All right, now this is the one where we say line from center to midpoint of chord. Okay, so that's essentially the difference between the two. Okay, so if it comes with a 90-degree angle like this diagram did, over here, it's line from center perpendicular to chord because that's what we've been given, and that means that it cuts the chord in half, therefore AM equals MB. Okay, so fabulous. We have now been able to establish how long AB is. What's the next step? What's the next thing that we need to do? It's a pleasure, Cassandra. OB is 2x given. Absolutely, Thelma. Yes, now we can do Pythagoras. Okay, so we can launch straight into Pythagoras from here. All right, we are allowed to say 2x squared plus 4x squared is equal to OA squared. And then over here, we're going to put our reason as Pythagoras. Let's just rub this out because it's in the way now. All right, and what we're going to end up with is an expression for OA squared. So OA squared is going to be equal to, so now comes our algebra, 2x squared is going to leave us with 4x squared. And then when we square 4x, we're going to end up with 16x squared. So that means that OA squared is going to be 20x squared. Right? Do you think it's important that we know what OA is? Should we work out OA? What do you think? Yes, I agree. In Tlantla, we're going to work out what OA is. All right, so therefore, whoopsie, why is the pen not writing? Therefore, OA. Yes, Dominion, you're asking a question?
I'd like to ask, when calculating for the angle OR, what formula are we supposed to use?
Which angle are you talking about?
For the formula OA, to find the angle for that.
Okay, so that formula that we're using to find OA is the theorem of Pythagoras. So we're not using the formula to calculate an angle because the theorem of Pythagoras can only be used in right angled triangles, and it's there for us to calculate the length of one of the sides in a right angled triangle.
Ma'am, the reason that I'm asking is that because AP for BA, we weren't given a term for that. Or is it because AC is equals to 8x?
Yes, it's because AC was equal to 8x. So that's why our starting point was to say, well, if AC is equal to 8x, then what this means for us is that AB is going to be 4x. Now, the reason for that is line from center perpendicular to chord.
So we're going to divide ax by 2 to get 4x.
Exactly. All right, so 8x divided by 2 gives us 4x. Quite right. That's exactly where it comes from.
Thank you, ma'am.
No problem. So now what you would find is if you did the root 20 on your calculator, it wouldn't give you root 20 as an answer on the calculator. It would simplify it. And what it would do is it would give you 2 root 5 and then x like so. Okay, so we can see some sort of bits and pieces starting to form of our answer, because look, there's a 2 there and an x there and a root 5 here, and we're kind of starting to get the same thing. All right, so we can see that our answer is definitely starting to take shape. Well, now that we've established how long OA is, what do we need to do now? So we've done Pythagoras. What do you think we need to do now? Grade 11s and matrics. What do you think the next step in our problem is going to be? Remember, okay, Liam Ogilvy, go for it. Liam?
So then do we have to state that OD is equal to OA, which is equal to 2 root 5x?
Absolutely. So it's making that connection. That's great, Liam. Making that connection between what we know now and where we want to go. All right, lovely. So I quite agree with you. Here we're going to say, but OA equals OD because they are radii. So that means that OD is also 2x root 5. Let me put it like that. Units long. Okay, awesome, fabulous. So now we're getting closer and closer. So we've used this bit of information as well. We've established that OA and OD are equal because of radii. Now, how are we going to work out what BD is? Elizabeth, go for it. There we go, minus 2x. Lovely. Subtract 2x from 2 root 5x. Good. Perfect. Okay, absolutely. Well done. That's great. You could use ratio. I suppose we could, Elizabeth, but we don't need to. We don't need to. We've broken our line OD down into its constituent parts, OB and BD. And if you remember in the beginning over here, we had established that if we wanted BD on its own, we could take OB, which is 2x away from OD, which is what everybody has been saying in the chat. Okay, so I think that's a good place to go. So what I'm going to do is I'm going to write. I know this is not great, and this is why this would only be online that I'm doing this. I mean, I should carry on writing underneath, but I want to write over here so that I've got my answer visible as well. Okay, so now we have established that OD is the sum of OB plus BD. So there's not a geometrical reason for that. That's what we can see in the diagram, right? And that means that if we leave BD on its own on one side, it's going to be equal to OD minus OB. All right, so as you've said, OD is 2x root 5 minus OB, which we know is 2x. So now they want us to, what do they want us to do? To get it into the same form that they've given us to over here, we need to factorize. Absolutely, Boitshepo. Okay, we've got to take out 2x. Yes, Liam, we've got to take out the common factor. 100%. So we're going to take out 2x, and then that's going to leave us with root 5 minus 1. There we go. Problem solved. Okay, so there was something non-routine, but hopefully not too difficult that we have been able to work through together. All right, well done. That was really great. Thanks, guys. I hope you enjoyed that. I certainly enjoy working through that with you. All right, are there any questions that you'd like to ask before we move on? I've got another question for us to do, something a little bit more difficult. No, we all good? Okay, Skahle, sure. What would you like to ask?
Ma'am, where did you get 2x?
When you say where, oh, you mean for OB?
Yes, ma'am.
Okay, so we were given that in the beginning. Okay, Skahle, over here, if you have a look, I'll just highlight it for you quickly in bright yellow here at the beginning. OB was 2x units. Okay, so it was something that was given.
Yeah, thank you, ma'am.
It's a pleasure, no problem. Okay, so now let's go down here. Right, this is a big one. All right, let's read the information first, and then we can move things out of the way and start having a look at how we're going to answer this question. All right, so another thing that I found that's also a little bit unusual, a little bit different, non-routine. O is the center of the larger circle, RTAP. OP is the diameter of the smaller circle, PSO. NP is a tangent to both circles at P. Rn is perpendicular to NP, and let P1 be equal to X. Okay, so now again, there is so much going on in this diagram. We're going to have to go up and down to move everything. So the first thing that they tell us is that OP is the center of the circle. So the minute we see that O is the center of the circle, what do we start thinking about? What key word is important here? The word center. I agree. All right. So what does the word center tell us? In this particular context, what do you think they are suggesting when they say that there's a circle center? Yes. What does it mean? What theorems should we be thinking of? Boitshepo?
Ma'am, it's OR equals to OP equals to OT, radii.
Yes, I agree with you. Absolutely. Quite right. You said R, O, O, P, and OT are all equal to one another. Absolutely. That could come in very important. We have a diameter as well. We certainly do. When we see the word center, right, we start thinking of all the theorems that have got the word center in them. So it could be angle at center is twice angle at circumference, for example. I'm not sure if we're going to use that in this case, but we may do. All right. If we've got a circle and we've got a line going through it, all right, then we also need to consider that that line is a diameter. All right. So now when we read the word diameter, what else does that mean for us? What do you immediately think of when you read the word diameter? Yes, Aisha, I agree with you. Radii. What else? So the word center also means radii. What does the word diameter mean to you guys? Ah, there we go. Angle in a semicircle. I quite agree. Angle in a semicircle. Absolutely. All right, so now that we've read that, okay, OP is the diameter of the smaller circle. So if OP is the diameter of the smaller circle, which angle is equal to 90 because of angle in a semicircle? Yeah, there's a few going on here, isn't it? Okay, so you're quite right. In the smaller circle, all right, if PO is the diameter of the smaller circle, it means that S1 is 90 degrees because of angle in a semicircle. But because ROT is also the diameter of the larger circle, it means, quite rightly so, that angle P2 and P3 are also equal to 90. Okay? There's even another 90-degree angle in this situation as well, because they've told us that NP is a tangent to the circle. So if NP is a tangent to the circle, then the radius is also perpendicular to the tangent. So in fact, grade 11s and grade 12s, we've got yet another 90-degree corner over here as well. All right, but that can get pretty confusing. All right, so we're not going to put too much information onto the diagram, although I suppose we can go and rub it off. But yes, P2 and P3 are 90. P1 plus P2 are 90. S1 is also 90. Then we read on a little bit further and we see that NP is a tangent to both circles at P. So immediately when we see the word tangent, what do you start thinking of? What theorems? Exactly. Quite right, guys. Tan chord theorem. Okay, so tan chord theorem. What else do you think about? Because there could be more than one in this situation over here. That's it, Thelma. Okay, tan perpendicular to the radius. Lines from a point, Aisha. Do you mean tangents from a point? Tangents from a point are equal? Yeah, there we go. Okay, tangents from a common point. Absolutely. Not in this particular diagram, but absolutely that is important that you start thinking about that. Okay, so tan chord theorem, and then the other thing that we need to think about in this particular case is that the radius or a diameter is perpendicular to a tangent. I mean, after all, that is the reason that the purple angle is 90 degrees, isn't it? Okay. No worry. Hi, Sense U30. I'm glad you're joining us. Welcome. It's no problem at all. Okay, so the first question, I think we better get started on this. I'm busy talking away here and our time's flying. All right, so Rn is perpendicular to NP. Is that on the diagram? Oh, yes, it is. Okay, so it's down here in the corner. Rn is perpendicular to NP. Lovely. Now, we're going to read the question, and then the first thing that we're going to say to ourselves is, what does this mean? Okay, so again, remember we've been through our steps. We've read the question, we've identified keywords, we've found connections to theorems. Now we're reading the questions. Whatever we can mark on the diagram, we've done so. We see there that angle P1 is going to be equal to X. Let's go and read the question. Prove that PR bisects ORN. What does that mean? Okay, and you can pop it into the chat. What does it mean? PR bisects ORN. What are they actually asking you to do here? Yes, and Paul, that is correct. So yes, you are correct with what you're asking me in the chat. Please scroll down a bit. Okay, no problem. Okay, cut the circle in half. David, that's a good suggestion, but it says prove PR bisects ORN. So yes, I agree with you. The word bisect means to cut in half. Absolutely. Cuts the line or goes through. Absolutely. Right. Liam, what do you think? I see you've got your hand up. Go for it.
Does it mean that we have to prove that angle ORP is equal to angle NRP? Angle
ORP is equal to angle NRP. Absolutely. Absolutely, that's exactly right. Now, Munashe, if I've pronounced your name correctly, and I certainly hope I have, we need to find or not whether R1 equals R2. That's perfect. Absolutely. Nokotaba, 100%. Okay, Tobile says prove PR divided into 2 equal parts. Absolutely. But what prove PR bisects ORN really means is it means show that, prove that R1 equals R2. Okay, because this line over here, PR, and I'm going to rub it out, this line over here cuts this angle in half. All right, so if a line cuts an angle in half, then it means that the two constituent halves, pieces, must be equal to one another. All right, so even though this question has some fancy words in it, prove PR bisects ORN, what it really means, all right, is prove that R1 equals R2. That's what we've always got to get down to, grade 11s and grade 12s, the nitty gritty. What does it mean? What are we exactly trying to do here? Okay, we've got to know that before we get started. Otherwise, we're just going to go round and round in circles. Okay, so now, again, we don't have a clear starting point. We need to try and think about some of the things that we have been given that is going to be able to help us in this particular situation. So often when we are trying to prove that angles are equal to one another, the angle will be equal to a certain thing. And then what we want to try and do is show that the other angle is equal to the same thing. So let's say, and this is not the situation in this case, but let's say an angle is equal to y. All right. If I can show that another angle is also equal to y, then I've proved that those two angles are equal to one another. Okay. So let's, now that we've focused on the fact that it means prove R1 equals R2. Well, how big is R1? How big is R2? What do we know about R1 and R2? Right. So go over and have a look at R1 and R2. Can anybody tell me something that we already know about either R1 or R2? When T1 be equal to R2. Let's have a look what's going on in the chat. Equal. We can find R1 by the sum of a triangle, sum of triangle. There we go, Kanyasile, excellent. R1 is 90 minus X. Lovely, well done. Okay, nice. Okay, so a great starting place for us. We can see that R1 is equal to 90 minus X. Reason? Angles of a triangle or angle sum and triangle or interior angles of a triangle, whatever it is that your teacher has showed you at school. All right, so now that we've established how big R1 is, we know that it's equal to 90 minus X. Now we need to show that R2 is also 90 minus X. And if we've done that, then we've answered our question, right? So now that's our entire aim from this point onwards, is show that R2 is also 90 minus X. Now, someone in the chat said something that was very interesting, but very important. Now, I just want to go back to where it was. Someone was saying something about tan chord. Or did I dream that? I don't know. I can't seem to find it now. Okay, so Viwa is saying T1 is X tan chord. Hi, Sense U30. What are you? You're welcome to unmute yourself and speak. T1 equals T1, Panita says. So quite right. P1 is equal to X. That has been given to us. Oh, sorry, that's actually not what I wanted to write. What I wanted to write, beg your pardon, sorry, is that T1 is equal to x, okay, because of tan chord theorem. Well done. Can everybody see that? All right, so angle P1 is the angle between the tangent NP and the chord PR. So the tangent NP touches the circle at P, the chord goes from P to R, all right, and then PR subtends T1 at the circle. Okay, so lovely. We've got the T1 is equal to X tan chord theorem. What's next? Is there a cyclic quad? There is in the big circle, which we will get to next if we've got time. Okay, so now it says someone's raised a hand. Does somebody want to ask a question or say something? What's next, guys?
Yes, ma'am.
Yes, Phil, go for it.
Can't you say that P1 equals O1 because of tan chord theorem? Which O1 would equal X?
Okay, I see. Now, do you know why that's not going to work? Because R doesn't lie on the circle of the smaller circle. Doesn't lie on the circumference of the smaller circle. It lies on the circumference of the larger circle. So if we had a line from this point over here all the way to there, then this angle over here would be equal to X, all right? But because this point over here lies on the other circle, lies on the larger circle, that's not going to be true in this particular case.
Okay, ma'am.
All right, Thelma, but good suggestion.
Thank you, ma'am.
So now people are saying R2 is 90 minus X. Why is R2, hang on a second. Left or Manolo. Okay, ma'am, you are too fast, sorry. Tyler, I haven't been taught the tan chord theorem yet. Okay, well, fair enough, then that would be difficult. I had just assumed, which is always a dangerous thing to do in maths, that everybody who had done the Watobe course would have done the geometry. So my apologies to you, Tyler. Then R2, 90 degrees, P1, T2. Yes, yes. Okay, so you guys are on the right track. All right. We've now shown that T1 is equal to X. Okay, you've got some lovely suggestions. Right? In order to get R2, can you see that RPT is a triangle? Someone has made this suggestion. RPT is a triangle. We know that P2 plus P3 is 90. So that means that R2 will be 90 minus X because of angles of a triangle. So now, in a logical stepwise manner, we need to say that P2 plus P3 equals 90, right? It's 90 because ROT is a diameter, so that is angle in a semicircle. So therefore, R2 is 90 minus X, as you guys had said, because of angle sum in triangle. And now we may conclude, therefore, R1 equals R2. That's it. Okay, Kashandra, the reason that T1 is equal to X is because of tan chord theorem. Okay, so here's the tangent, here's the chord, and the chord subtends T1 at the circle. Okay, so the angle between the tangent and the chord is equal to the angle in the alternate segment. Is there anybody else who's lost? Boy, Pedro, please explain why P1 equals P3. Okay, P1 equals P3 because, do you remember in the beginning we had someone, I don't know who it was, but someone had spoken about radii. OT equals OP equals OR. So if OT and OP are equal to one another, then P3 also has to be x because of angles opposite equal sides. Okay, yes, because of radii, absolutely, Monashe. Okay, it's angles opposite equal sides. Bushule, did you understand? I explained again why T1 was equal to X. Okay, we're not calculating anything, Mushle. We're just discussing stuff. Okay, we're just talking about, someone asked a question and I just answered it. Someone said to me, why is P3 equal to T1? It's not something that we've actually dealt with yet, but it is something that we are going to deal with. Okay. Oh, we don't have much time. Let's see if we can finish this question off. All right. So the next thing that we need to do is prove that ROS, I don't know if I'm going to be able to finish this in time. Okay, ROS, so that's this angle over here is ROS. Prove that ROS equals PAT. Okay, so that's that angle over there. All right, so prove that ROS equals PAT. All right, so I'm going to try and do this as fast as I possibly can. I'm sorry I'm rushing here at the end. This is what I would do. All right, so in the big triangle, in the big circle, we can see that we have T1 at the circumference, which means that O1 has to be equal to 2x because of angle at center is twice angle at circumference. All right, so that's the first thing that we need to establish in this particular case, all right, that O2 is going to be equal to 2x. Now, if that is indeed the case, is there a way of us being able to work out how big O2 is since it forms part of our answer? Well, yes, this is where knowing that P3 was equal to X would be important, because then we can work in triangle OPS and we can establish that angle O2 is also going to be 90 minus X. All right, so very quickly, I'm just going to get this down. Okay, these are the bits and pieces that we need. O1 is equal to 2x. Angle at center is 2 times angle at circumference. All right, also S1 is 90, angle in a semicircle. Which means that S2 is going to be equal to 90 minus X because of the angles of a triangle. So what I'm doing now is I'm establishing how big angle ROS is. So therefore, ROS is 2x plus 90 minus X. So it means that ROS is 90 plus X in size. Now again, if I want to establish that two things are equal, if I can show that they're equal to the same thing, then I've established that they're equal to one another. So now my entire aim is to prove that the angle at A, so PAT, is also equal to 90 plus X. All right, and this, I believe, is where knowing that there was a cyclic quad is so important. Someone did point that out in the very beginning. I can't remember who, but whoever you are a real smarty pants. So well done for seeing that. I'm going to highlight it for the rest of you. This is a cyclic quad, all right, in the big circle. Oh, my lines are revolting. Sorry, grade 11s and matrix. Okay, there is the cyclic quad. What do we know about cyclic quads? The opposite angles of a cyclic quad are supplementary. They add up to 180 degrees. Don't we know how big R2 is? We know that R2, we've already established that R2 is 90 minus X. Okay, so what we can say is that R2 plus A is equal to 180 degrees. right? Our reason for this, opposite angles of a cyclic quad are supplementary. Right, R2 we know is 90 minus x plus a equals 180, and therefore if we make a or PAT the subject of the formula, then take the 90 over and it would be equal to 90 plus x. Okay, and that's why they are equal. ROS is 90 plus x, PAT is 90 plus x, so therefore we may say that ROS is equal to PAT. Okay, now I know there were some questions. All right, so let's go back and see if we can answer these. Okay, how is O1 equal to 2x? So Jordan, angle at center is twice angle at circumference. So the angle at the circumference is T1. Okay, the angle at the center, if you put your fingers at R and at P, the angle at the center is O1. Go back to R, go back to P, and now follow R and P through to T1. Okay, so that's why. All right, O1 is TX because of angle at center is twice angle at circumference. R2 equals O2. Yes, correct. Muhle, that's quite right. Sipusihle, R2 equals O2. Yes, how's O1 equal to 2x? Just explained it. P2 equal to R2. Yes, P2 would be equal to R2, but I'm not sure that that's going to help us in this situation. Next question. How is S2 equal to 90 minus x? S2. I didn't talk about S2 being equal to 90 minus x. I never said anything about S2. Please explain how O1 is equal to x. I have, if you want Tyrese. So again, if you've got your fingers at R and at P, the angle at the center is O1. Go back to R and RP. Follow the lines to T1 at the circle. So angle at center is twice angle at circumference. In Shantla, ma'am, there is minus x and plus x in the answer. Okay, but now remember, when you take something over to the other side, it's going to change its sign. Okay, so I'll go down a bit. Okay, so yes, but here if you have a look, all right, I'm saying that ROS is 90 plus x. I'm also saying that PAT is 90 plus x. Okay, so I'm not saying that 90 minus x is the same as 90 plus x. That's not what I'm saying. All right, but I have been able to show that ROS is 90 plus x, and I've also been able to show that PAT is 90 plus x. Remember, when this goes over to the other side, it's going to change its sign. Okay. Why do we leave out O3? O3 doesn't form part of our answer in this case, Malzondi. Okay, we don't need O3 to answer this question, just like we didn't need S2 to be able to answer this question. Okay, so even though sometimes angles are named, we're not necessarily using them. Like P4, we also did not use in this particular case. Okay, anyway, I hope grade 11s and grade 12s that you've enjoyed this session. I know that the TAs and I have certainly enjoyed being with you and helping you through these problems. And please, please do join us again at the same time at 5 o'clock. On Thursday, we're going to be looking at some slightly different questions. But hopefully it's going to be things that are relevant and interesting and are going to help you. Oh, good. I'm glad you enjoyed them, Paul. That's really important to me. It's the greatest pleasure. Pleasure, Tatso. Thank you, Panita. Thank you, Tobila. Thank you, everybody. Cool, Rory. Love the smile. Thanks, Inam. Oh, I love the hearts. Thank you. You know what? If you want extra work, Nhlanhla, go and have a look on the department's website. They've got extra questions they've got past exam papers for grades 11 and grade 12s. Okay. It's a pleasure. Good night.